sigma, or really, it's not, is it? This is a sample. I should be calling these x bar and s. Okay, what was our standard deviation?
11.8058.
Perfect. Okay, so we know we can use calculators to get that. By the way, one of my calculators disappeared yesterday, so you guys need to locate it and make sure it gets back to me if you want to continue using my calculators in class, which you do because you don't want to do standard deviations by hand. So, part B says determine the percentage of all patients that have an HDL between 34 and 69.1 according to the empirical rule. The empirical rule tells us how many standard deviations from the mean we are. So we need to figure out how far these values are from the mean. So if you did your mean minus 34, we get okay. Now, you could also, if you wanted to measure the 69.1, you subtract off your mean from that. We need to know how many standard deviations each of these things represents. So if you take this number and divide it by your standard deviation, 23.4074, divided by our standard deviation, 11.8058, what do we get? 1.98. So how many standard deviations do you think we would call that? 2. Why did it not come out to be exactly 2? We have rounding error, right? We rounded our mean, we rounded our standard deviation.
Never mind. It was my fault. It was 69 instead of 69.
Oh, okay.
I got 5.59.
Gotcha. That's 2 standard deviations.
Wait, how do you know that?
I took this number and divided it by my standard deviation. So if I took this one and divided it by my standard deviation, what do you get? One. Okay. We have to think about what this is. With the empirical rule, you've got your mean in the middle. My 34 was 2 standard deviations below. And this one was 1 standard deviation above, right? We look back at our empirical rule. I told you that 68% of the data fell within 1 standard deviation. So that means 1 standard deviation above the mean is actually what percent? 34. You take the 68, half of that's above and half of that's below, so that's 34, right? So this part right here, the 1 standard deviation above, that would be 34% of my data. Do you have a question?
No.
And the 1 standard deviation below is 34%, right? Now, we also need to consider that second standard deviation below. We said 95% was within 2 standard deviations, right? So, a couple different ways you could think about that. if you took that 95 divided by 2, that's 47 and a half on each side of the mean. So if you preferred, you could think that this whole part represents 47.5%. Would it be easier to think about it that way? Okay, let's do that then. So instead of breaking it up into 34, we can just say we know that the second standard deviation is 95%. 95 divided by 2 is 47.5%. So if I add those together, we get 81.5% of our data should fall between those ranges.
I'm confused with the 47.
Okay. So here's our bell shape.
Like, I don't know how you got the 90 or whatever you divided.
That was the empirical rule that I gave you yesterday. It said 2 standard deviations is 95%.
But why is it
So
40?
95%, half of that's above the mean and half that's below it. So I divided 95 by 2. Okay. So empirical rule is talking about how far you are from the average. So here's your average. It's saying within this range, that 1 standard deviation from here to here, that's 68% of your data. Okay, so that would be half above and half below. Within 2 standard deviations, that's from here to here. That is 95%. Since the mean's in the middle,
Yeah,
you
that
split
makes
that in half. Does that make more sense?
Yeah.
Any other questions? Okay. Part C determines the actual percent of patients that have an HDL between 34 and 69.1. So we would actually have to count how many patients fell in that range between 34 and 69.1. Might be easier just to, here, let's just exclude the ones that don't. Which ones do not fall in that range? My 85 is too big. 82. 75. Okay, so count up how many patients is that? We had 54. I marked off 9 of them. So that means 45 out of my 54 patients did meet that requirement. So in actuality, it was 83.3%. So the empirical rule wasn't too far off. Now, how come the empirical rule isn't exact?
Maybe it wasn't exact.
Right, was my data a perfect bell curve? No. So that's why it's close, but it's not exact.
Because would there be a time unless you skew all the way to unless you like take it.
Yeah. Okay. Any questions there? So the next piece I want to talk about is Chebyshev's inequality. This one is not on your formula sheet, so if you want to write it down, you may do so. It would go, I would put it in chapter 3 and just squeeze it under your empirical rule if you want to write in. So the empirical rule only works if you have bell-shaped data. Chebyshev's works for any data, so even if it is not bell-shaped, this will work. Okay, what it tells you is that for any data set, at least 1 minus 1 over k squared times 100% of the observations lie within k standard deviations of the mean. Chevy chefs, we need to determine the percent of patients that have an HDL within 3 standard deviations of the mean. So the formula is 1 minus 1 over k squared times 100%, which you could even leave that off if you needed to. That 3 standard deviations, that's my k. So essentially, my k is 3 here. Yep, k is the number of standard deviations. So if you type this in, the 1 minus 1 over 3 squared, if you want, you can multiply it by the 100. If not, you just have to move your decimal to change it to a percent. And we get 88.89%. Okay, you'll notice it's not as strong as the empirical rule. The empirical rule says 99.7%. This is only 88.89 because it allows for, if your data isn't in a perfect bell shape, it is skewed, so you have to have a wider window there. Determine the actual percent that had a HDL within 3 standard deviations of the mean. We need to find out what 3 standard deviations of our mean is in this problem, don't we? What was our mean? What'd you guys tell me? So to get 3 standard deviations of the mean, you have to do that minus 3 times your standard deviation. And that plus 3 standard deviations. Okay, so this one, 3 standard deviations would be between 21.99 and 92.82. So that's my window. If I look at my data, are there any numbers here that do not fall in that range? So again, we said our range had to be 21.99 and 92.82. Is there anything outside that window? No. So what percent of my data actually fell in that range? 100%. Why was it higher than the 88.89 we predicted?
Because it was a bell.
This one was a bell shape. Chevy Chef says at least this much. It has to be at least 88.89%. It could be more. And the more symmetric your original data is, the more it will actually be. Remember, we said that original one was bell shaped. Does this follow the empirical rule? Empirical rule says how much of the data has to fall in that window.
What window, the 3?
The 3
Isn't it the
99.7%. So 100% would certainly fall within that. And that's again just because our original data was already symmetric. Okay. Questions on empirical rule or Chevy Chef? It's basically just a prediction of how much data is going to fall within a certain distance.
Will we get that one on the test or?
I might go in and add it to the formula sheets. I'm debating. Still. Okay, the last thing I want to talk about is a weighted mean. This is like what we have when we calculate your GPAs. Okay? So a weighted mean is found when you take the variable times its weight and divide by the sum of the weights. Okay, again, it's probably a scenario where it makes just as much sense to actually do a problem as it does to try to look at some formula that's given to you in your book. So let's look at this scenario. Bob goes to the by the way nut store and creates his own bridge mix. He combines 1 pound of raisins, 2 pounds of chocolate covered peanuts, and 1.5 pounds of cashews. The raisins cost $1.25 per pound. The chocolate covered peanuts cost $3.25 per pound. And the cashews cost $5.40 per pound. What is the cost per pound of this mix? This is like a weighted meat. So, how many pounds of raisins do we buy? How much do you pay for the raisins? Okay, now we have to add in our chocolate covered peanuts. How many pounds do we buy? And how much do we pay for chocolate covered peanuts? And finally, we buy cashews, and cashews are? Okay, we are trying to find the cost per pound. This numerator, that's giving me my cost. What am I going to divide by? The weight. How many pounds did we purchase? We bought 1 pound of raisins, 2 pounds of chocolate, and 1.5 pounds of cashews. So you would have to add those weights together to get our total number of pounds. So now we just need to calculate this. This is, remember, a cost. So how are you going to have to round it? 2 decimal places. So we get that this cost is $3.52 per pound. That's